Good afternoon, sir.
Yeah, good afternoon, Yongjie. Yeah, good afternoon, everyone. Make sure you sign your attendance, yeah? Make sure you sign your attendance. Already opened the instead, yeah? Okay, so I guess I can start the recording so that we can start today's lesson. Okay, so I hope everyone can see the slides. Yeah.
Yes, sir.
Okay, thank you. All right, so this is where we actually stop. Yeah, this is where we actually stopped the other day, right? So I'm sure, okay, I'm pretty sure that all of us still confused or still thinking, or some of you maybe already can catch how to get this, okay, slowly and so on, okay, because there's a few of your friends actually directly approached me to get further understanding on this, okay. So I hope you already able to get this slowly, right? And today, okay, of course, today we are also going to look at another way to also obtain this A cross B. All right. Oh, okay. Sorry. Sorry that I forgot to change my pointer. Okay. Right. So as I mentioned, okay, so today we are going to learn how actually we can also obtain this A cross B, which means this equation, okay? So this long equation the other day, okay, we already learned, okay, how we can actually obtain by using this matrix method, okay, this matrix method. So as long as we recognize I, J, K, and then we know that is plus minus plus, okay, I is plus, J is minus, K is negative, plus, okay, and then we can get the minor, and from there we already know the magnitude of 2 times 2 matrix. Then we will be able to get this equation, this last equation. Okay, all right. So today we are going to look at even maybe for you is simpler. Okay, but I still like this one because this today's one we need to actually have additional column. Okay, we need to write down additional column, but probably you like it. Okay, let us have a look. Okay, I'm sure also a few of you may have already do some studies, some research on how actually you can calculate, okay, this A cross B even easier, in an easier way, okay, probably, okay. Anyway, okay, let us have a look at this Sarah's scheme. Okay, sometimes the reference are written as Sarah's rules, okay, Sarah's schemes, some Sarah's method, okay. So it doesn't matter, okay, it doesn't matter as long as we already got the way to calculate this A cross B, the way he introduced, that is already very, very good. Okay, so he also introduced this A cross B in terms of matrix, of course, okay, in terms of the magnitude of the matrix method, right? And okay, there is additional column, okay, we need to actually add in so that we can calculate it in the simplest way, in certain way, okay, which probably easy for you, which means we need to write it in this way, okay, right? So we just need to add another column, which is for this I column J, okay, this column, okay, the first column and the second column, all right? So we just need to add this additional column, right? So we add this additional column, then we will be able to get the equations already. Okay, you'll get the equations. So how actually to get this? So it is very simple. We just make sure we put this variable together. Okay, all these we put together. And all these, we just have a positive in front of them. Okay, we just have the positive. So this is a plus. Okay, this is a plus. That means all these variables that we multiply, we will obtain a plus. Okay, a positive. That means, okay, for example, for this first one, I, all right, for this I, so we will have A, Y, B, Z, I. Okay. And for J, we have A, Z, B, X, J. And then for K, we have A, X, B, Y, K. All right. So this is how we get. Okay. Right. So we have A, Y, B, Z, I, A, Z, B, X, J, A, X, B, Y, K. Okay. So this is for the first way. Okay. Then the second is we go upward. And this is placed as a negative. All right. So we will have for K, right? For here, for K, we have AY, BX, K. For I, we have AZ, BY, I. And then we have for J is AX, BZ, J. All right. So we have these equations here. Okay. A negative of BXAYK, negative of BYAZI, negative of BZAXJ. All right. So if we put I with I together, J with J together, K with K together, then we will get what we actually obtained earlier as well. It's similar. All right, it's similar. So for I, as you can see, we have this. For J, we also have this. And for K, we also obtain the same way. All right, okay, same way, same value. Can understand? Anyone understand this? Today's method?
Yes, sir.
Yes, sir.
Okay, good, good. So, do you think the earlier one or this one is easier?
Definitely this one.
This is easier.
Yeah, definitely this one's easier for me, sir.
Okay, understand, right? So of course, in terms of graphical, okay, how we actually look at it, okay, we can just draw it, write down, and then we can get the answer immediately. But for the earlier one, there's still mathematical involved, right? Okay, a lot of mathematical involved. So that's why it looks like this one is easier. It's just that we need to add 2 columns, okay, 2 columns. Okay, good. Okay, so now you have been introduced, okay, few ways for actually find out what is A cross B, okay, if we have the components, okay, if we have the components. Of course, if we just have the magnitude and directions, we still have to use the magnitude and right hand, okay. So magnitude means the definitions of the magnitude A cross B, which is AB sine phi, okay, and then use the right hand to find the directions, okay. Right, good. Okay, so let us look at the example to actually make our understanding much better, okay, enhance our understanding, okay, right? So this is the first example, okay, again, you see, we have this example, okay, so vector A has a magnitude of 6 units, okay, and then is in the positive x-axis, okay. A is 6 units in the positive x-axis, and then B has magnitude of 4 units in the xy plane and making an angle of 30 degrees with the positive x-axis. Okay, and then additional information, it having a positive y component. Okay, it has a positive y component. So again, it enhances us where is the directions of the vector B. Okay, so now they want us to find what is A cross B. So what should we do first? Yeah, what should we do first? Anyone?
Write the vectors in IJK form.
Write the vector in IJK form. Okay. Any other suggestions? If you do that, then how are you going to find it?
Sketch the diagram.
Sketch the diagram.
Okay. Okay.
I think, but for me, I would like try to find the angle between vector A and vector B.
Oh, okay. Okay. So it means that, we actually can sketch, right? So to have a better diagram, okay, better pictures of how or what is our first step, okay? The best, as I mentioned earlier, we try to sketch out what is actually these vectors about, okay? So we have this x-axis, y-axis, all right? So we were given that vector A is in the directions of x-axis. So this is vector A, exactly in these directions. So this we know is vector A. And then they told us vector B is 30 degrees with the positive x-axis and having a positive y component. Of course, it will not be downward, right? It will not be downward, but it is upward. Okay, it will be upward here. So this is vector B. So therefore, we actually already obtained the angle between vector A and vector B because it's already told us vector B is making 30 degrees. No, vector B is making 30 degrees with x-axis. And from this diagram, it is actually the angle between vector A and vector B as well. Okay, so it is very obvious now, correct or not? So we were given the magnitude of both vectors. right? The magnitude of both vectors. And also now we already know the angle between them, right? So the easiest for us to solve, of course, okay? So we have the vector of A, we have the vector of B. Therefore, we have A cross B is AB sine theta and magnitude. Direction is using the right hand. You see, A and B is in the XY plane. Then, of course, there will be z-axis. So if you are taking A cross B, okay, then we will be obtaining the resultant in the z direction. So that's why by using the right hand, we will be obtaining the resultant directions, which is k. All right. So we just substitute. Okay, substitute the value of A and then of B and then sine theta. Okay, so therefore we will obtain the resultant of A cross B, which is equals to 12k. All right, 12k. All right, so this is the direct way for us to find. But of course, as what you may probably say just now, okay, you may want to find a component if you want to find the vectors by using the matrix method, okay, by using the matrix method. So, okay, so we have actually find by using the component, okay. So of course, okay, again, if you want to use these equations, you have to derive it out as what we do just now. Okay, all right. So here, as you can see, after we found Cx, which is Ay Bz minus By Az and so on, and then at the end, we only have Cz, which is non-zero. Okay, so of course Cz is k. All right, so that's why we have also A cross B is equals to 12k. All right. Understand? Any questions? So the first method, of course, is the easiest and the fastest. Okay, instead of us go and find the component. Okay, right? Go and find the component. Of course, the vector here is just to show you. All right, just to show you. You don't really have to find out this. You already able to calculate A cross B using this method. All right. Okay. So this vector here is just to show you what is actually vector A look like and B look like. Okay. All right. Understand? Any questions?
Sir, I have a question. The components of vector B, how did we get 2 root 3 I plus 2j?
Oh, you just use the triangle. All right, you just use the triangle here. Okay, let us look at this. So we have this vector B. And this 90 degrees, just like here. Above here in this diagram, this is 90. Okay, this 90 degrees as well. Okay, all right. So we were given that this is 30. So if that is 30, that means this is 60. Right. Okay. So if that are those the angle, then we will be able to write it out. Okay. So we have this as 1, 2. Oh, sorry. This is 2. This is 1. 1, 2, 3. Okay. That's how we obtain. Okay. For sine 30 is 1 over sub 3, if cos 30 is 2 over sub 3, okay, and so on. Can get it? Oh, sorry. Is this correct? Okay. Is this correct? Anyone? Anyone?
The magnitude for A, or like the vector for A, is 6, right?
Oh, okay, okay. No, it doesn't need to be that value. Okay, you just remember the 30-60 degree rules. Okay, okay. Nobody actually mentioned here. Is this correct? What I written here? Anyone? I hope you
Should be,
remember.
sir, should be sub 5. Is it?
No.
So I thought this vertical line should be square root of 5.
Reverse.
Sorry?
The 2 should be at the hypotenuse, and sub 3 should be at the bottom.
Yes, I misplaced. Yeah, thank you. Yeah, it should be. Here is 2. Here is 3. Okay. Just now, who is saying just now should be 6?
Sure.
Yeah, because I can't see your name. Yeah, so I hope what I show here, of course, is not based on the magnitude. Okay, it's not based on magnitude, but it's based on the rules of the angle. Okay, it's just the angle rules, 30-60 rules. Okay, so if you remember this, okay, so that's why you can always use this value every time when we find sine 30, cos 30, or sine 60, cos 60. Okay, right? So
yes,
we don't really have to place the magnitude as 6. Okay, we don't have to, because if you want to put it as 6, then you need to do certain calculations again to modify this and this, all this, right? So we just take this as a general. Okay, take this value here, the angle, as a general, for us, just for us to find the angle. Okay, just for us to find the sine theta, the cos theta, that's all. Okay, just to simplify this sine theta and cos theta. That's why we obtain B as in this form. Understand?
yes, sir. Thank you.
Okay. Okay. All right. Okay. So anyone has any other questions?
No, sir.
Okay, thank you. All right, so we move on to the next one. Okay, to the next question. Okay, so the second example, okay, the second example we have is given by 2 vectors. Okay, it's given by 2 vectors. So we have A equals to 4 plus 3, and B is 5 minus 2. Okay, 5 minus 2. So find the vector product. Okay, find the vector product A cross B. Okay, A cross B, and they want us to express in the vector unit notation. All right, and then again they ask what are the magnitude and directions of the vector. You see, so this is a little bit additional calculation for us. Okay, not only finding the resultant in the unit vector notation, just like what we normally express in IJK, but now we also will need to find the magnitude and directions. Okay, all right. Okay, so if that is the case, okay, if that is the case, of course, the simplest way is for us to use the vector method. Correct or not? Or anyone like to use other methods? Okay, we use the matrix method. Okay, so we have ijk. All right. So matrix method here is very direct. As you can see, if we take I, okay, this is how we actually use matrix method. Okay, so if we take I, you can see that the minor here, okay, the minor here contains 0. So I is 0. Correct or not? If we take J, everything here is cancelled. Again, there is 0 in the minor. Okay, in the minor is also 0. But when we take K, okay, when we take K, then we cancel all this. So it means cancel with all the 0. Right now. So what left is only K. All right. What left is only K. Of course, to write in details, then you have to remember all the variables just now. Okay. All right. But to be direct, that is how we can easily find. Okay. So to be in details, this is how it is look like. Okay, you can see that. Okay, for I, all the terms contain 0, and J, all the terms contain 0. Only K, that is not 0. Okay, only K, that is not 0. So that's why we have this 0I, 0J, and only K is not 0, which is equivalent to minus 23K. Okay, minus 23K. All right, and then the questions want us to find the magnitude. So how do we find the magnitude of this vector A cross B? Yeah. How to find the magnitude? Anyone? Anyone? Magnitude?
Take the absolute value of the coefficient.
That's right. Okay. So to find the magnitude of A cross B, so we just take the coefficient, right? We just take the coefficient of this A cross B, right now. Okay. So take the coefficient of A cross B, which means take the coefficient of this value here, this vector here, sorry. Okay. So what we obtain, of course, is just the number 23. Okay, number 23. Okay, because K is a unit vector, so the magnitude is 1. All right, and of course the directions in the negative z-axis. Okay, so that if the question wants us to give in terms of magnitude and directions. Okay, magnitude and direction. So we have magnitude and directions as well given for the answer. Okay, right. So any question is very direct. You understand?
Mr. Tan?
Yeah.
Yeah, can you solve it using the other way?
The other way?
Yes.
Which one?
The one you showed earlier.
Oh, you mean the latest one?
Yes, please.
It's going to be something similar like this. It's just that you will need to write this out first. I, J, K. So you will have 4, 3, 0, 5, minus 2, 0. So you need to write out another column. Oops, sorry, this is J. Okay, so you have 4, 5, 3, minus 2. All right, so you can see that for I, this is what you have. You can see that it's going through 0. That is this one, 3, 0, right? 3, 0. And for J, you have these, okay, 0 and 5, okay. this is not number, okay? So 0 and 5, so you can see J, okay, 0 and 5, okay? This is 0 and 5. Of course, this is minus here, this is minus, that's why it is a positive, okay? This is positive. And then for K is 4 minus 2, this is 4 minus 2, all right? So that is how we obtain using this method. Same thing for a negative, right? So this is a negative. All right.
Okay, thanks, sir.
Okay.
So why are we taking just negative 23 as the magnitude?
Again, we get the modulus, right? The modulus of this A cross B. So it means that it becomes like this. Okay, we have magnitude of vector A cross B. That is the magnitude of this, negative 23K. Right now. That means this is equivalent to minus 23 and K. Okay. So modulus of this minus 23, of course, is 23. Right? And the modulus of K, okay, the magnitude of K is 1. This is a unit vector. Right? This is unit vector. Magnitude is 1. Understand?
Yeah, thank you.
Okay, welcome. All right. So we just get the whole magnitude. Of course, if you want, okay, you can also do this. Okay, use the Pythagoras. It means that you want to find A cross B. Okay, vector A cross B. Then what you will have will be component of vector AB. For I, we know is 0. And then for J also 0, but for K is minus 23. Also can, all right, also can, same thing, okay? But of course, it's a slightly longer calculations, the way we do it, okay? So anyway, both way also can, okay? It doesn't matter, both way also possible, all right? Can? Cannot?
So if you're using the Pythagoras theorem, the answer will come as positive 23.
Yes. You see, this is power of 2. So you become positive, and then you square root it, so you get 23 as well. Okay.
So when we're writing the answer, the negative here is describing the direction of the vector.
Yeah, here the negative is the directions of their components. Yeah.
Thank you, sir.
Okay, welcome. All right. So that is the second example. Okay, I hope everyone already clear. All right. Let us look at the last example. Okay, example 3. Okay, so this example 3 also want us to find the vector products P cross Q and its magnitude. Again, they want us to find magnitude. Okay, but they didn't ask us directions, luckily. Okay, so they didn't ask us directions, because it is a 3-component vectors. Okay, 3-component vectors. So either they want to actually ask us with x-axis or with y-axis or with z-axis. So that is a lot more questions then. Okay, right? So normally if it is in 3 components, then generally they will just ask about magnitude only. Okay, so let us look at this. Okay, again, as the same way, I like to use this matrix method. Okay, so I have, because from here I can see immediately, I can write out, okay, for I can write out, okay, 5 times 3, okay, and then 0, minus 0, okay, all right, 5 times 3 minus 0, write out for I, okay, so that's how I look immediately in the matrix, but it's depends on individual. All right, it depends on individual, so that we can write out these equations. Okay, so that's how I obtain. Okay, 5 times 3 and then minus 0, 0. Same thing for j. Okay, so for j, we know that is a negative. Okay, so we know that is negative. So 2 times 3. Okay, 2 times 3 and then 8 minus 8 times 0. Okay, right? And then similarly for k, we have 2, 0 minus 8, 5. Okay, all right? So from here, then we will be obtaining the resultant vector of P cross Q, which is 15I, 6J, and 40K. Okay, they are all in meters. Okay, they are all in meters. So we have here meters times meters. It should be meters squared. Okay, so I missed out that square. All right, so should be here meters times meters, right? As you can see. Should be meters squared. All right. Okay. So now they want us to find the magnitude. Okay. So the only way for us to find the magnitude is using what?
Pythagoras.
Yes. Okay. That is the only way. Of course, we cannot use the modulus of one magnitude only, because here they have 3 components, not only 1 component. Okay, right? So we need to use Pythagoras. Okay, so we find all these components, square and sum up, then we get 43.14. Oh, again. Okay. Right. Okay. So that is the magnitude of P cross Q. All right. Okay. So anyone has any questions? So that is the end of our lesson 2. So I hope everybody understood very well now how actually we'll be obtaining the summations of 2 vectors, of 3 vectors, and then how we actually obtain the products of the vectors by using the scalar only, and then by using a dot products, and finally using the vector products. Okay, let us look at the summary of this. Okay, so we already try to understand what it means by scalar, what it means by vector. So everyone know that. Okay, the difference between them is just the what? What is the difference between scalar and vector?
One gives a direction and one does not.
Yes, that is the difference. All right, one gives the directions, the other one didn't. All right, okay, good, very good. All right, and then as we say just now, we already learned how to add a vector, of course, geometrically, and of course, to be more accurate, we try to add them by components. Okay, by components that will give the best, okay, the accurate results for our summations, okay, or of course deduction. Okay, right? So then we come to multiplications. All right, so for multiplication, as we say, we have 3 ways of multiplying. Okay, one is just by a scalar, a number. All right, so for only 1p, we get 2p, or we get 5p, or we get negative 5p, and so on. Okay, so it depends on the scalar, the constant that we multiply with that vector. All right, so here they gave is minus 2.5j. All right, okay, minus 2.5. It means probably p initially is j. Okay, right? Of course, they didn't tell us that. Okay, just assume. All right, okay, and then the second way is for us to multiply vector with the vector is a scalar product, which is the dot. Okay, so when the question put a dot, okay, when the question put a dot, then we know exactly how to multiply them. Okay, it means that is a scalar product. Okay, that is a scalar product. Our answer should be a number only, just a number. That's why it's called scalar products. Okay, and the last way is the cross products. Okay, the last method is the cross product. So remember, if the question gave us a cross, okay, then the product is a vector product. So we should obtain a vector. Okay, we should obtain a vector for our resultant multiplication. Okay, all right. So that's why they call it vector products. Okay, all right. So that is the summary of this lesson 2. So I hope everyone will be able to grasp, okay, either a little bit and slowly you should increase the understanding. Okay, if you still have certain uncertainties, okay, difficulties to understand, please Teams me. All right, please Teams me. Okay, so
Sir, I have a question.
Yes.
So the only time we're not going to use the Pythagoras theorem to obtain the magnitude is when there is just one component.
If one component.
Yes, sir.
If
Like,
one component you can use if you want. It's just that you will have additional writing. Just that. Okay. Is it what you mean? Is the previous just now? The previous.
Yeah.
Okay. Yeah. So if it is just one component, it's very direct for us to use the modulus. It's very direct to just use modulus. Yeah. And
thank you, sir.
okay. Welcome. Yeah. Okay. Good. Yeah, good questions. So if just one component left, it means the resultant is only one component, then we can immediately use the modulus. Okay, we immediately use modulus to find the magnitude. We don't have to use the Pythagoras. Okay, it takes a longer writings there. Okay, right? Okay, so if you already got the view of this lesson, then let us refresh back from the beginning by looking at some questions. Okay, of course, we go with a simple one, and then slowly, it's harder one. Of course, it will come later in your exercise, probably those harder one. Okay, additional questions in your additional exercise. Okay, now is tutorial. I believe everyone have done the tutorial. All right. Okay, so let us look at these first questions. Okay, first questions. So they ask us to state whether the following example is a vector or a scalar. This is very confused or not? All right. Okay. So we just have to be firm whether it's a vector or a scalar. So the first one, is it a vector or a scalar?
It's a scalar.
Scalar.
Scalar, the first one. Okay, everyone says scalar. Why? Why is scalar? Any reason?
It only shows
direction.
No direction.
No direction, sir.
Yes, it's only magnitude here, right? Magnitude. We try to find on the left, on the right, in between the words. There's no word saying right or left, okay, or north. Correct or not? Yeah, that's right. Okay, B. Okay, B. A velocity of 3 meters per second on a bearing of 115 degrees. So is it scalar or vector?
vector.
Yeah, why?
There's 115 degrees indicating this direction.
Correct. All right, so this is the direction, okay, 115 degrees, okay, bearing, and the magnitude, of course, is 3 meters per second. How about C? A force of 35 Newton acting 30 degrees west of north.
Vector.
It's a vector quantity.
Yes, also a vector. We have magnitude, we have direction. Good. Okay. How about D? 57 seconds.
Scalar quantity.
Yeah, that's right. This is very obvious. It's a scalar quantity, just magnitude. They gave us 57 seconds. What is that? What does that mean? Okay, so just a period. Okay. And then E, 5.2 meter per second.
Scalar.
Scalar? Sure?
Yes.
It's not velocity?
It's a
No.
scalar.
It's a scalar.
It's a
It's a
scalar
scalar.
quantity.
So this is not a velocity?
This is speed because there is no direction.
Yes, that's right. Because there's no direction, so that is just a speed. It's not a velocity. Okay, right? Okay, good. How about F? 152 meter north.
Vector quantity.
Vector.
Why?
Says
Shows the
north.
distance and the magnitude.
Yes. Okay. Although it is very short. Okay. Just 182 meter north. Okay. But we know exactly. Okay. That is the distance and that is the direction. Okay. Good. Okay. Very good. Okay. Everyone can recognize that. Okay. I'm sure. Okay. If these kind of questions, everyone get 100. Okay. How about the second? Okay. Example. Okay. How long should a line be to represent a 19 Newton force? Okay, 19 Newton force. If you use a scale of 1 centimeter is 2 Newton.
9.5 centimeter.
9.5 centimeter. How you got it?
19 Newton.
divided by 2.
Yes. Okay, so we just take 19 Newton divided by 2 Newton to get the length. Okay, so it's 9.5 centimeters. Okay, and then how about B?
3.8.
3.8, sir.
Centimeter.
3.8?
Yes.
Not
Centimeter.
2.5? How to get this?
19 divided by
19
5.
divided by 5.
Oh, okay. I thought 5 divided by 2. Okay, good. Okay, everyone is confident now?
Yes, sir.
Okay, good. All right, so it's not being disturbed by my voice. Okay, just disturbing. Okay, all right, good. And then the third example. Okay, we have the third example. So a jogger, or you are actually jogging, okay, having a light exercise of the day, okay, from point A there, okay, it shows us point A, okay, and then we would like to find is the total distance traveled from A to B to C to D and to E. All right, so what is the total distance? How do we find?
13, sir.
Again?
13.
Oh, 13. Okay.
13
Everyone say
kilometers.
13?
13
Yeah.
kilometer, yes, sir.
Okay, the distance, of course, is 5 plus 2 plus 3 plus 3. So that is 13 kilometers. Great. How about the displacement?
1.5
Okay.
1.5 kilometers south.
South. Oh, yeah. South.
Ah, lucky. Got someone remember, yeah? If not, being shoot again. Okay, so everyone agree? The displacement is?
1.5 kilometers south.
Yes. Good. Very good. 1.5 kilometer south. Okay. If you just give me 1.5 kilometers, you get wrong answer. Okay. All right. Yeah. Okay. Good. Very good. Okay. Colleen and Colleen. Okay. Colleen give the answer for A. Okay. Yeah, this is the directions. Okay, I forgot to let you see this. Okay, why we say it is south. Okay, right. So that's why we obtain south, because they told us it's going east. Okay, it's going east. Right, it's going, this is east. All right. Okay. Yeah. So next okay, we look at the fourth example. Okay, oops, okay, sorry. So this is the fourth example, right? So the resultant of two vectors, okay, they gave us here, A and B, is perpendicular to the vector A, and its magnitude is equal to half of the magnitude of vector B. So what is the angle between vector A and vector B? Hey, you see, exactly by the diagram, okay, exactly shown by the diagram, okay, is the resultant. Okay, so this is the resultant. All right, so A and B, okay, added together obtain the resultant which is perpendicular to A, but the magnitude is half of B. Okay, very interesting. So anyone? Yeah?
Wait, sir. Thinking, sir.
Okay, good, good. Yeah, sure.
Give us a bit of time, sir.
Sure, I gave you 2 minutes, 1 minute.
2 minutes, sir, please.
Okay, sure. Yeah, this probably involve a little bit of calculations in mathematics, physics, so it's a mixture, so you should frequently try few different exercises here and there, then probably you may actually met with this kind of questions, then you'll be able to answer it in a faster way. All right.
So it's what?
Is it 150?
120 degrees.
Ah,
120.
okay. Someone already gave the answer. 150 degrees. How you get that? Someone give 30, 90 plus 60, okay, 150. Someone give 120. Colin get 150 also. All right. So someone already tried. So we have a look at the answer. Where's my pen? Okay. All right. So it says, okay, it says that this R, okay, this R is half of B. So R is half of B, right? I'm not sure if you do the same way as I am going to show you here, okay, but don't worry, you can actually message me if you think your method is also correct. Yeah, okay. So here you can see that R is equals to half as what they told us, okay, half of the magnitude of vector B, right? And then, okay, and then from this diagram, Okay, from this diagram, we know that A is perpendicular to R, means that, okay, we can see that this is perpendicular, right? So it means that R is just the component, okay, one of the component of vector B, right now. So that is, we can write as B, okay, cosine beta, right now. Everyone agree? B cosine beta is R, right?
Yes, agree, sir.
Yes, sir.
Okay, good. Yeah. So now we have this has to be equal, right now. So we can write cos beta equals to half, which means beta is equals to arc cos of half. Right now. Yeah.
Yes.
So just now, yeah. So just now we just learned about this 60, 50. Sorry, 60, 30. Right, 1, 2, and third 3. Yeah. So cos half, that means beta is 60 degrees. All right. So therefore, the angle between A and B, okay, the angle between the angle between A and B, which is this one, right, is 90 plus 60. Right now. Okay, everyone got it? Yeah?
Yes, sir.
Okay, good. All right. So yeah, you can slowly understand this. Okay, if you still unable to grasp it, okay, never mind. Okay, so let us look at the last one. Okay, of course I have a few more. Okay, just look at the time. Okay, still able to do it. Okay, so this example 5. Okay, it says there are 3 vectors A, B, and C. Okay, and they satisfy A dot B equals to 0, A dot C equals to 0. But then it says a vector A is parallel to which vector? Yeah. How is this? A dot B, 0. A dot C, 0. So A should be parallel with which vector?
B cross C.
B cross C. Why B cross C? Any reason? So that your friends understood why is that B cross C? Why not B dot C or A cross C?
Because A dot B equals 0, that means A and B is perpendicular, and A dot C equals 0 is also perpendicular.
Okay.
So
why what happened to B cross C then?
B cross C will generate a K vector, and maybe
Generate
a vector may parallel to A. No.
Okay. The answer probably you can give is okay. Yeah, it's correct. A dot B is 0. A dot C 0. It means that A and C. Okay. If we have something like this, right? This is a 3 dimension, right? If you have this as X, Y, and Z, okay, it doesn't matter A, B, C in which, okay? It's just that probably I would like to take A and somewhere here, okay, right? A is somewhere here. So B is somewhere here. And then C is somewhere here. So that's why it says A multiply with B. Oh, sorry. Okay. A multiply with B is 0, right? A dot B 0. A dot C also 0, right? Because they are 90 degrees here. Okay. They're also perpendicular. All right. So we can see that. Okay. We can see that X and Y, okay, contains this BC. Okay, BC actually is in the XY plane, right? It's in the XY plane. Of course, if B cross C, it will actually create a vector which is perpendicular. Okay, B cross C, it will create a vector which is perpendicular to this plane, XY plane. All right. So of course, it will be parallel to vector A. Okay, of course, it will be parallel to vector A. All right. Okay. All right. Good. Very good. Okay. Last question. Okay. Last question, because it's already 6. I hope everyone also got this. Yeah. You have A cos theta I, A sin theta j. So a vector B which is perpendicular to A is given by what vector? Which vector? Which one? Yeah. Okay, never mind. You can go back and think. Okay, thank you very much, everyone. Okay, thank you very much. I hope everyone can understand this lesson very well now. Okay, if not, you can slowly digest and ask me questions if you have. Okay, all right. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Okay.
Bye
so much,
bye.
sir.
Take
Thank you.
care.
Bye bye.
Don't
Yeah.
forget to drink water, sir. Bye.
Bye.
Thank you so much, sir. Bye-bye.
Thank you. Thank you. Welcome.
Thank you, sir.
Yeah, thanks. Oh, okay. Someone is trying to give me the answers. Okay. Thank you. Thank you. Thank you, everyone. Bye-bye. Have a nice day.